Hello everyone and welcome to today's video. We're going to be starting chapter 12 with this one, and we'll be going over the surface area of prisms and cylinders. Now in the previous chapter we talked about 2D figures. This chapter we are talking about 3D figures. So a lot of the information will overlap. We'll actually be using everything we learned last chapter as a base in this chapter. But now we're going into 3D figures. So let's start off with, what is a prism? Well, a prism, is a 3D figure that has two bases, so base 1, base 2, that is connected by lateral faces. Okay, and these lateral faces, as you can see, are just lines that connect the two bases together and that are parallel and congruent to each other. Okay, the lateral faces intersect the bases at the base edges. And then if it is perpendicular to the base, we have our altitude again. Now, as you can see probably from the pictures, there will be some times where the lateral edge is an altitude because it is perpendicular to the base, like the definition says. But there are other times where the lateral edge is not perpendicular to the base. Instead, the altitude comes out of the figure, as you see in this one. Okay, this is called an oblique prism. So you still have the two bases, the two figures that match each other, but it's not going straight up and down. It's kind of tilted off to the side. So, as a recap, prism, 3D figure with two bases, connected by lateral edges or faces. Okay, let's keep going. Now, when we're talking about the area, the surface area of prisms, there's actually two kinds of area. We have the lateral area and the surface area. Okay, now sometimes if you go on Google, you'll see this as LA versus SA. The PowerPoint, as you can see, just uses L. I'll use the capital letters when I'm doing 3D figures just to help distinguish it from the 2D figures. Now, the lateral area of a prism is the sum of all the areas of the lateral faces. So imagine if you were going to color the sides of a box, but not the top and bottom. So you would color this piece, you would color this piece, and then you would color that back piece. But you would leave the top and the bottom uncolored. The parts that we colored, are the lateral faces, and therefore that it is the lateral area. Now the equation, this one right here, only works for right prisms. Okay, so it only works when the lateral edge is the altitude. It doesn't work for oblique prisms. You need to do something different for those. So if a solid is oblique, it'll tell you, but otherwise assume that all the solids are right solids, because they're the ones that the formula works for. Now before we move on, I want to make a small point about the equation itself. So as you can see, lateral equals P times H. The P stands for the perimeter of the base. Okay, so the perimeter of the base, whatever that base is, that's what you're looking at. In this case, it's a triangle. In a different figure, it could be a rectangle. Okay, whatever the base is, that's the perimeter you're looking for. H is the height of the prism. So H will always indicate the distance between the two bases. Okay, this is not the height of the base itself. Okay, because remember, as we start adding in our stuff from last chapter, there's a lot of our variables that will overlap. Okay, you'll have heights in both equations. It's very important you keep these variables separately. Okay, this H refers to the height of the prism or the distance between the bases. Okay? If you can keep that straight in your head, you'll be all right. Now in this one, we are told the length of the base of a regular octagonal prism is 6 inches, and the height is 11 inches. So first off, we gotta draw our figure. And after several attempts off camera, there it is. Now, we know that each side length of the base is 6 inches. And remember, the bases are the shapes that match. So that means that each of my side lengths, despite how it looks, these are all congruent. And they're all 6 inches. And then the height is 11. The height is the distance between the two bases, so that's going to be this bit right here. So 11 inches, and then we've got 6 inches over here. Now we need to find the lateral area. Now the lateral area, as a reminder from the last slide, is equal to the perimeter times the height. Okay, so first off, we've got to find all of our pieces. Our first piece is the perimeter. Now this one's rather easy because they give us our pieces, but as we discovered last chapter, sometimes you might need to find your pieces. But in this case, we have 6 times 8, or the number of side lengths, and that gets us 48. Lastly, our height we know to be 11 inches. Now before we go any further, don't forget your units. 48 is the perimeter, so this is going to be inches. And then 11 is the height, it is also inches. So when I plug this into my equation, I have 48 inches times 11 inches, which gives me 528 inches squared. Which makes sense, because even though this is a 3D figure, we're still asking for the area. And in area, it's your units squared. Okay, so here's the first one. This is for lateral area, our equation being the perimeter times the height. Now our second form of surface area is the surface area, the total area as it is sometimes called in some internet and worksheets that we may come across. Now the total area includes the top and the bottom. So whereas beforehand in the lateral area, all we cared about were the lateral faces, now we care about the lateral faces plus the top and the bottom. And that exact phrasing almost translates directly into our equation. So we have L, which is perimeter times the height, plus 2 times our bases. Now the reason why it's 2 is because there's 2 bases. 1, 2. So first you find your lateral height, and then you add it to 2 times the area of the base. Now here's where we got to be careful. Capital B here stands for the area of the base. The area of the base. Now we'll be using capital B and lowercase b in some of our equations. So please make sure you keep the 2 pieces different. Okay? Lowercase b indicates a piece. Okay? The base of a 2D figure. Capital B indicates the area of the base figure. Okay, so make sure when you're labeling your equations, you keep those 2 things separate in your mind and in your work. Let's go ahead and do a problem. So we want to find the surface area of the triangular prism. Now I want to pause here and mention another fact about prisms. All prisms, as you might have guessed by now, are named based on the bases. So if I have a rectangle, this is actually a bit more of a square. If I have a rectangle, this would be a rectangular prism. okay? If I have a square, well, it'll be a square. Squares are special. If I have a triangle, it's a triangular prism. If I have a hexagon, if I have two hexagons, this is going to be a hexagonal prism. Okay, if you have a octagon, if you have two octagons, octagonal prism. If you have a heptagon, a seven-sided figure, that'll be a heptagonal prism. And you get the point. Prisms are always named based on the bases. So you can always tell which one is your base and which one is your lateral area, or your lateral faces. So in this one, I have a triangular prism. So the triangles are my bases. So let's go ahead and write out our equation so we can figure out our pieces. Surface area is equal to the lateral area, which is perimeter times the height, plus 2 times the area of the bases. Okay? So my perimeter is the perimeter of the base. In which case, I have 12, 12, but I need to know the hypotenuse. So in order to find the hypotenuse, we're going to do Pythagorean theorem and figure it out. So I have 12 squared plus 12 squared is equal to c squared. And the hypotenuse comes out to 12 root 2. So our perimeter is going to be 12 plus 12 plus 12 root 2, which is 24 plus 12 root 2. Nothing wrong with that for an answer. Especially if you notice that the instructions say that we are going to round to the nearest tenth. So that makes it even better because we're going to be rounding this anyway. So I'm going to take this piece and I'm going to plug it in and find the rest of my lateral area, which is just the perimeter, so 24 plus 12 root 2 times the height. Now remember, this height is the height of the prism, okay? Not the height of the base. This is the height of the prism, which is 8. So I multiply those together and I will get a decimal, and that decimal is 327.7645. Okay? Keep your decimals out to the 4th decimal place during the problem. Okay, so that's one piece. Now let's move on to the next piece. And I need to find the area of my base. And since the base is a triangle, it's going to be the equation base times height divided by 2. Now again, I'm going to point out the difference between the lowercase b and the uppercase b. So the lowercase b stands for the base of the 2D figure, not the base of the prism. Capital B is the base of the prism. Okay, so one more time. Lowercase b, the base of the 2D figure. Capital B, the base of the 3D figure. Okay, just keep those straight in your head as we go on. So my base will be, actually don't need that right now. And then since I have a right triangle over here, it's going to be 12 times 12, since those lengths are the height and the base, divided by 2, which means that my area of my base is 72. And now that I have both my pieces, I have my lateral area, I have the area of my base, I'm going to plug them into my surface area equation. So 327.7645 plus 2 times 72. And you can go ahead and plug all that in the calculator. And it says round to the nearest tenth, so my answer is going to be 471.8 millimeters squared. Okay, this is my final answer. Notice how everything is labeled. All of the work that went from my perimeter is next to it. All of the work that went towards my lateral area is next to it. Okay, everything is labeled. Everything is in nice, neat order. If you need scratch paper for these problems, use scratch paper, but you need to make sure your work is neat. And now we come to cylinders. Now cylinders are nice because they are still prisms, but as you can see, the two bases are two circles. Now a lot of the vocab word stays the same. You have the altitude, which is still perpendicular to the base, and you have a right cylinder and an oblique cylinder. Now that is clearly a picture of an oblique prism, but the principle still remains the same. An oblique cylinder would be a cylinder that is tilted, and therefore looks something like this. Ta-da! Now, a new vocab word is over here, and that is the axis of the cylinder. The axis of the cylinder is the segment where the centers of the bases connect. Okay? Now that axis is helpful because sometimes it is the altitude. And when the axis is the altitude, it's a right cylinder. When the axis is not the altitude, then the cylinder is oblique. And again, just like with prisms, if it's an oblique cylinder, the height will come down off the side and be perpendicular with the base anyway. It just won't be within the figure. Now the equations for the cylinder, for the lateral area and the surface area are actually the same equations. It's just that because they're cylinders, we write out the equations for the circles. So since the lateral area of a cylinder is the area of a curved surface, we have to have pi, because pi goes with curves. Just like the right prisms, the lateral area equals pi, or the perimeter times the height. But since the perimeter of the circle is called the circumference, we just use that equation. So the lateral area of a cylinder is equal to 2 pi r, aka the circumference, times the height. Okay, and it's the exact same thing if you look at it for a regular prism. And the same pattern repeats when you have the surface area of a cylinder. It's still going to be the lateral area plus the area of the bases. But it'll look different because instead of just putting lateral area, we'll write out the equations for the circles. Now, whether you write out this one or this one, it comes out to the exact same thing. But this second one gives you a better roadmap and helps you find all of your pieces. Let's do some problems. All right, now let's go. I'm going to do the first one with you, and then you will do the second one on your own. So here we go. I need to find both the lateral area and the surface area. So let's just start off with writing our equations. My lateral area is going to be the perimeter times the height, or 2 pi r times the height. And then my surface area is going to be 2 pi r times the height plus 2 pi r squared. Okay, so just looking at my equations, I see I need the radius and the height. And then as you look at your problems, you can see this one in particular gives you the radius and it gives you the height. So I don't need to do a whole lot. I can go straight to plugging it in. So for lateral area, I'm going to plug in 2 times 5 pi times 9, which is going to be 10 times 9 pi, which is 90. Okay? Inches squared, because it's a lateral area. Now to find surface area, I'm going to take my lateral area, which is 90 pi, and add it to the 2 pi r squared. Okay, so 90 pi comes straight down, plus 2 times 25 pi. And as you can see, it just follows nicely from here. Leave pi as a symbol in your answer. Okay, a cylinder qualifies as a circular shape, and therefore pi sticks along because it works for circles. And there's our answer, the lateral area and the total area. The video is going to pause. Go ahead and do the next one. And here are your answers to 3B. Again, you start off with your lateral area first, and this problem is nice to us still. It gives us the diameter and the height, and all you gotta do is find the radius and then plug into the equations. For the most part, cylinders are going to be nice to you. There's only the two pieces, the radius and the height, to find, and a lot of your pictures will give it to you. But always be careful. You could have a problem where you have to find the pieces and then plug them into the equation. But that is it for right now. Please write down any questions you may have, and I'll see you in class. Bye.